Okay. Now let's have a look at a new problem. So far it's a conditional probability and independence. It's a new problem. We have two failed dice are rolled, and the event is sum equals to 7. Event 1, this is event 1. Event 2 is the first die shows some score, that is 1, 2, or 6. Because if you roll the die, definitely it is going to show up some value, 1 or 2 or 6. Now the question is, E1 and E2, are they independent? 7. E1 sum equals to 7. Two failed dice. And the first die shows some score 1, 2, or 6. So what is let's first have a look at what is the probability of E1. Probability E1 sum equals to 7. In what condition the sum will equals to 7? 1 and 6.
2 or 3.
So this is the first toss and the second toss, second die, right? First die, second die. 2 and 5. 3 and 3. 3 and 3 add together 6.
3 and 4. Sorry.
Okay. 3 and 4. And 4 and 3. 5, 2. Or 6, 1, right? Why this one is different from this one? Because it's first die or second die. Okay. But what is the total number of possible outcomes? That's 6 by 6. Then you have 36 possible outcomes. And how many of this? So this is 1, 2, 3, 4, 5, 6, right? So you have 36 possible outcomes, and this is 6 out of 36. So what's the probability of E1? That the sum is 7. So 6 over 36 equals to 1 over 6. So what's the probability of E2? Okay. What's the probability that the first die shows 1? 1 over 6. What's the probability the first die shows 2? But here we are saying showing some value r. This r could be 1 or 2 or 6. Okay. So now if you fix r to be 1, it will become 1 over 6 for any r equals to 1, 2, or if you specify I is 3, then this is 1 over 6. If you specify r is 1, then this is 1 over 6. That means we're going to specify r value. For a particular r value, what's the probability that it show up in the first die? That is 1 over 6. So what is the relationship between E1 and E2? E1 and intersect E2. So now how to translate this one? This translation here is probability first die shows r and sum equals to 7. Agree? This is the intersection, right? Both of them happens. The first one shows r and the sum equals to 7. Then what is this probability? Are they equals to the multiplication of these two? So for each fixed r equals to 1 to 6, there exists a unique set, a unit score of second die. Such that sum equals to 7. For example, if the first die shows up 1, the second die has to show up 6 so that the sum equals to 7. Okay? So therefore, probability E1 intersects E2 is actually equals to 1 over 36. Because if you fix R to be 1, then it has to be 6. So that's 1 over 36. So this actually equals to probability E1 times probability E2. So the answer is yes, E1 and E2 are independent.